All right, so this is just a quick video to remind you how to write a linear function, write an equation to a linear function. So if you think back to Math 1, you guys learned y equals mx plus b. Remember that m is your slope and b is your y-intercept, where you cross the x, or where you cross the y-axis. So when I look at this graph, I see that my y-intercept is +1. Now I'm going to count my slope. Remember, your slope is rise over run. If your line slants downwards, that means your slope is negative. So I go down 1, 2, 3, 4, and I run to the right 2. So my slope is -4/2, which means my slope is -2. So the equation for this function is f of x, which is the same thing as y, equals my slope, -2, times x plus my y-intercept, which is 1. Now the domain says be sure to use inequality notation. I want you to take a look at this domain. You see that this is an open circle, and that open circle is right above -3. So that means that -3 is not included in the inequality. So it's not going to have an equal bar underneath the inequality. And you'll notice that everything else in this function is bigger. All of your input values, or your x values, are bigger. We're going in the right direction. Greater than. So that means that -3 is the smallest, and all of your x values, or your solutions, are greater than that. So x has to be greater than -3. Again, because this is an open circle, we want to make sure that we use the greater than symbol, not greater than or equal to. So my inequality, x is greater than -3. All right, so let's look at the next linear function. So you see on this linear function, we actually don't cross the y-axis. So we're going to have to do some thinking. So if I were to look at my slope, I see that I cross a grid line here and here. So I can count my slope. I see that I go up 1 and to the right 1, 2, 3. If I repeat that pattern of up 1 and to the right 1, 2, 3, I then am able to see that my y-intercept equals +2. And we've already counted our slope. We know that it's a +1/3. Up 1 and to the right 3. So my equation, y equals mx times b. So y equals, or f of x equals 1/3 x plus 2. Y equals mx plus b. So there's your function. Now we need to look at the domain. So our domain is going to be, think about in terms of a number line. We're going to have an open circle here and a closed circle here. And we're talking about the space in between. So remember that this is an and function. So when I look at the smallest x value, I see that it's at -10. So all of the solutions x are greater than -10. But I also need to look at the largest value. And the largest value is -3. So this means and x is less than or equal to, because this is a closed circle, -3. So remember that and functions can be written as a compound inequality, meaning we change the order there and flip it. So my inequality for this is -10 is less than x is less than or equal to -3. So that's what I'm going to put in my blank here. It says, what is the domain? Well, -10 is less than x is less than or equal to -3. All right. So let's take a look at this function. We have to choose which one of the piecewise functions, meaning which one of these rules actually matches the graph. So let's first of all just kind of identify what types of functions we have. So this first function is an absolute value function of some sort, right? It's going to be some type of absolute value function. The second function, well, that's a parabola. So that's going to be y equals x squared, some type of that, right? The parent function, y equals x squared. And then when I look at this last function, the last piece, that's just y equals mx plus b. That's a linear function. Okay, so now we're going to look at our domains. Now we want to focus on our domain values. So when I look at my domain for the absolute value function, I see that the smallest number is -4, and it's included, so -4 is less than or equal to x, which is less than, not included, +1. All right, let's look at the quadratic function. So my domain, +1, is less than or equal to, closed circle, and the largest value, 5, which is less than or equal to 5. So 1 is less than or equal to x is less than or equal to 5. And then our last function, our linear function, we have an open circle. So 5 is less than x. 5 is less than x. Well, we don't know how far that goes, right? It just continues forever. So we just know that x is going to be greater than 5. All of our x values are greater than 5. So let's take a look at our domains, first of all. So in our first piecewise function, the absolute value function has a domain of -2 to +1. So we know that this is not correct. When I look at my second absolute value function, I see that this domain is from -4 to +1. However, -4 is included. Remember that this had a closed circle, and the +1 is not included. This had an open circle. So this one can't be correct. Okay, this should have been less than or equal to, and this should have just been less than. So now let's move on to the next one. So when I look at this choice right here, when I look at my domain values for my absolute value function, -4 is less than or equal to x, which is less than 1. That seems to work. What about my quadratic function? So I verify that it is quadratic. 1 is less than or equal to x is less than or equal to 5. That's correct. And lastly, x is greater than 5. So this is the piecewise function that represents this graph.